So hello class, this is going to be the last video of the week, and hopefully you guys enjoy it because I'm pretty embarrassed having to look at and record these videos. So I hope you like it. This one we're going to add up all the pieces that we've learned so far and to figure out how to find the zeros of a function that we couldn't factor or do anything with. So for example, I'm going to give you this worksheet tomorrow, so if you could take a blank sheet of paper and take notes on this, it'll make your work tomorrow much easier. So say for example, here's a function. It says, looking at number 1, it says f of x equals x to the third plus 9x squared plus 23x plus 15. And they're going to give you one factor. X plus 5 is already one answer. I'm trying to find the other factors. Okay? And since you know one of the factors is x plus 5, I already know one of the solutions is negative 5. Right? And then I know you guys are bright enough to figure that out. So like for example, in this problem, we're not going to do it, but since one of the factors is x minus 3, I already know one of the answers is 3. Okay, so remember, our whole goal is to graph this or figure out how this function looks like. You know, based on n behavior, you already know how it looks like on the left. You already know how it looks like in the right. But I don't know how those zeros look like in the middle. So I'm going to do essentially a pretty long process. The first step, and I'm going to start numbering these so that you guys sort of get it. The first step is how many solutions is it supposed to have. Again, you look at the degree. For this problem, my degree is 3 solutions for sure. Okay. The second step, what I'm going to do is I need to figure out, gosh, what am I supposed to do? I'm going to figure out how many of these solutions are positive and negative. Okay. So what you're going to do, I'm using Descartes' rule of signs. Hold on one second. Okay, sorry, I'm back. What I'm going to do is I'm going to use Descartes' rule of signs to figure out how many possible positive and negative possible solutions there are. So what I'm going to do is I'm going to look at, for possible positive, I'm going to look at my sign changes, right? So I have plus, 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 plus. How many sign changes I have? 0. So without a shadow of a doubt, I know there are 0 possible positive solutions. Okay, so far? Now I'll do the negative. Remember, to do negative, I'm only changing the signs of odd exponents. So the first one I have x to the third, because it's an odd, what was once positive, I'll make negative. I have 9x squared now, because it's a squared, that will stay positive. I have this plus 23x, because it's an odd, instead of a plus, it's now going to be minus. And this plus 15 will stay plus. Now, how many sign changes do I have now? I have 1, I have 2, and I have 3 sign changes. So for my negative, my possible negative ones, I now will have either 3 or 1 possible negative solutions. Okay. So essentially, I have to find out. There's 3 solutions. They could be all negative. There could be 1 negative and 2 complex. But I really don't want to know what they are. And I already know one of them is negative 5. So how do I figure this out? So first step, I found out how many solutions. And the second, oh, I don't know why I changed the color. And the second step, what I did is I used Descartes' rule of signs to figure out how many do I have. Now, how do I figure out which they are? Next one, I'm going to use, it might be easier for me to label this. So this first one is, let me put this away, is fundamental theorem of algebra. Okay. Fundamental theorem of algebra, and the second and third ones, this is Descartes' rule of signs. Let me write in cursive. It's easier on a mouse. Descartes. Okay. Step 4, I'm going to use the rational root theorem, and that's what we practiced today. Okay. What I'm going to do is I'm going to take all the factors possible using P over Q. Actually, we did this yesterday. I apologize. P over Q. P is going to be all the factors of the last coefficient. So the last one is 15. What are all the factors of 15? I know some of you like the Dora the Explorer. But all the factors of 15 are, yeah, correct. 1, 3, 5, 15. Q represents the coefficient, and remember all these are positive and negative. So this might take me a while, but just know all those are positive and negative. Now for q, I want all the possible factors of the first coefficient. The first coefficient is what? Yeah, it's 1. So all the factors of 1 are just 1. So sorry if this is disjointed, but my camera just crashed, so it might not connect. But so last thing I said was the last is 1. So rational root theorem, or rational zero theorem, says that all the possible answers are p divided by q, which since I'm dividing all of them by 1, all the possible answers are positive minus 1, positive minus 3, positive and positive negative 5, and positive negative 15 are all the possible answers. And the last step, step number 5, and I'm cutting into question number 3 here. The last step is I have to test all these numbers. Okay, there has to be 3 solutions, right? Because we figured it out. And the cool thing is that we found out that there are 0 possible positive solutions, right? So I'm not going to test positive 1, positive 3, positive 5, or positive 15. I'm done with that. I'm going to check all the negatives. Okay. Now, here's another thing I'm going to do. Remember it says one of the factors is x plus 5? Yeah? So let me divide, or let me use synthetic division with negative 5. Okay, so I'll put negative 5 inside the box. And I will put in the coefficients. Okay, so far. Now let's do some synthetic division. I'll drop the 1. Negative 5 times 1 is negative 5, which is 4. 4 times negative 5 is negative 20. I get 3. Negative 5 times 3 is negative 15. I get 0. Now, this should make sense because we already proved that negative 5 was a factor, so I should get 0. Now that I know that negative 5 is a factor and this is what happens when I divide it, I'm going to change this problem. Okay, so instead of saying f of x equals that, I'm going to say this problem is now f of x equals x plus 5, since it's a factor. Yeah. And then I'm going to, remember I take the less degree. So since my degree used to be x to the third, I'm down here. I'm going to say 1x squared. Okay. I'm going to say 4x plus 3. 4x plus 3. So the cool thing about this is that I've already factored it once, and now all I care about is this one right here. Now, what's even smarter for you is that this one is factorable, right? Can't I factor this quadratic? This I didn't know how to factor, but this I do know how to factor. So let's factor it. I'm looking for numbers or factors of 3 that if I add them, I get 4. Yeah, there's only really one factor of 3, so it's going to be x plus 1 and x plus 3. Now I found my 3 zeros, negative 5, which we already found, negative 1, and negative 3. So what you just found, or what we just did, is found the 3 roots for this problem, and now I could graph it. Because remember, originally, looking at this problem, I had no idea how to graph it. And it makes sense because it said I was supposed to have 3 or 1 possible negative solutions. I ended up having 3 negative solutions. So this is correct. I can now graph it. The world is happy again. So that's it. So we're going to practice more of this tomorrow. I just want to give you a quick demo video to sort of speed this up, and then we'll practice more tomorrow. So take care. I'll see y'all tomorrow.